All right, welcome to class assignment number 10. This one gets just a little bit more difficult. This is still radio line development now, and working with a cone, a round taper, and it's just going to be pushed straight to one side. So maybe that's eccentric. Um, so this and it is eccentric to one side, I guess. The center lines of the cone will line up on center in one direction and then not in the other direction. So I'll kind of show you. Like the other cone that we did in assignment 9, it can be just done with a front view, but we do a little tricky manipulation with our drawing to use just the front view, and then I'll go ahead and show you what's going on in the top view, because you could do this as a top and a front view, but it's unnecessary. But I do want to show you to kind of to explain of what we're able to do in the front view to get the information without actually drawing another view, but what's actually going on. So anyway, I'll show you what's going on there. So it's just a cone that's going to have a large diameter of 8.625, 8 5/8, as if it was matching 8-inch pipe, and a small round diameter, which I'll probably draw the large diameter on the bottom and the small diameter on the top, and small diameter matches 4-inch pipe, so it's 4.5 inches. It'll have an elevation of 6 inches. So let's go over to AutoCAD. Yeah, here we go. So I've just got my instructions up there in case I forget, but I want to show you how I draw this in first. Let's see here. So you can start with either one. I'll just start with the large bottom here. So I'm just going to start with a circle with a diameter of 8 5/8. Great, and that's going to end up being my development circle, and I'll draw across the quadrants here to represent the base of this cone here. And then this thing has what I do next is I use the elevation to draw next. So I'm drawing the front view right now. And I'll draw this with a dashed line just for a reference line first, and I use a line for this too. I'm going to stretch this line in a minute here, but the finished elevation of this in the front view here is 6 inches. So I'm going to go ahead and draw that in 6 inches tall, and then this is going to be the top that I'm going to draw here of which is the smaller round diameter. So this is going to be 4.5 inches right here. Great, and then this would finish off just back here. So this shows, I'm going to snap this off where I started back over here. So what this shows, and I'll go ahead and I'll trim this out to clear it up just a little bit right now. So I'm going to trim this thing just to be ready to use as my development circle. So there it goes, trimmed out. So this is the base of my cone. This will be the top of my cone here, and it's flush on one side, so this cone just pushes everything over to one side. To kind of give a flat-bottomed cone, or so it is eccentric in this view, and then in the top view it will be they will share the center line in the top view, and which isn't totally necessary. It doesn't. I don't need all the information I have is actually right here if I manipulate kind of my orientation lines a little bit here. So I'm going to do that, and then I'm going to explain where I got that information, probably in this first part, and then maybe I'll make it part 2 that I finish doing the development. But let's continue to draw this in. So there's a lot similar here to how we drew the other cone, and I don't need to put a reference circle up here. I can definitely change this to a solid line. It is the top of my cone. I can change these too, but first I'm going to, like I did in the other one, I need to define the apex point up here where these two sides are going to cross. And so I'm just going to start with this one, and I'm going to lengthen this thing. It's just a line, so I'm just going to lengthen it visually to where I can see it crosses the straight side of this cone. So about 10 inches. I'm just going to put in 10. And whenever I do that, I always make sure it hasn't pulled off of, still in line with the top and still in line with the bottom. So, and it looks like I've carried it over far enough that this one will now be able to intersect it. So I'm going to lengthen this thing up, and there it is. This intersection point pops up. I'm sure I have intersection point selected. So if I escape off that, now that's just, I've been able to now define this apex point right here, which is where my whole pattern is like really based off of. Very similar to my other cone. So that's good. Now what I can do, just for, like, I can leave those lines, and you might just see me just go ahead and draw these in as a solid line too, just because they are an object here, solid object line. So I'm going to do that. That's pretty standard. It does have a midpoint. You know, I could pull a midpoint up to break up this pattern a little bit so far, to break up my object view here. I can pull a midpoint off of here and up to the apex. I could tuck this in too. I'll just leave it long. I don't know. I could tuck it. I'll just leave that one for a minute. And so there's kind of a start to my pattern here. What I'm going to do next is I need to divide my development circle. So I'm going to go ahead and do that. So I'm going to divide this by 6, get my node points, and then I'm going to do something different here. And this is where this changes. So with a little bit of manipulation here, I can get true lengths. So I can kind of incorporate the information from a top view into the front view by doing a little trick with my node points here. And this may be a little unclear of why, and that's why I'll probably break and then explain, draw a top view and explain like why it lines up this way. But what I do with just this one view is I've got the node points established. They're popping up here. I'm going to take just a reference circle here, and I'm going to, and when I break for a minute after I get this done and stuff, I'm going to number these points kind of our standard numbering system. I might start with this point as 1 here on the straight side of this object, but essentially what I'm going to do here first is I'm going to pull 1 to node point 2 there, if I name it 2. And then I'm going to kind of repeat this. And essentially what I'm doing is this type of an eccentric cone flat on one side, it does, if you see, it does create a Pythagorean theorem. So, and yeah, it does create the ability to use Pythagorean theorem because I've essentially established a right triangle here by going to an apex point. So I ended up just kind of like I'm working off the base point here, the 90-degree corner of that triangle, and I'm going to pull these other circles to the node points. So that's node point 1, 2, there's 3. I'm going to repeat this for node point 4 and on around 4, and then 5, and then 1 more, 6, and then 7 is already there. I mean, it's just like it would be 1 snapped over to 7. So what I do with these now is I've just kind of manipulated my node points a little bit different to incorporate what's going on in the top view. So one thing I can do is I can trim these out. All I really want is, what I'm looking for is where the node point, based off of this corner point that's 90 degrees here, relates to the base of the cone here. So I'm only looking for this little section, like swinging an arc as this is the center point over to where it meets the base of my cone. So those are the points I'm really looking for, and how I've kind of manipulated that node point look, rather than just going straight up perpendicular to my base like we've done before. If I do that, I don't quite pick up the true lengths, and so this is what I'm using this trick to pick up true lengths. And so I'm going to trim this stuff by this point here, And all of these, I could select them all. So yeah, let me just grab these ones too. I'm going to select all those and trim out everything that I don't need. Oh, maybe I didn't quite do that right. Let me trim again. Trim that out. All my lines. And I gotta do both of these, maybe? No, I know what I gotta do, sorry. I gotta trim. I gotta look at it right, but I gotta trim this out, grabbing all those, and this and this. Now if I select those, I should be able to just trim out what I don't want here, which is most of that circle. All those circles had the center point of the corner of my triangle here, very corner of my cone, and I get this different kind of look that incorporates the top view into the front view without doing a whole entire top view. So I'm going to break for just a minute, and I'm going to number my points, and I'm going to take these orientation lines where they meet the base of my cone up to the apex, and then from there I'll pick up. All right. So all I've done, I just took, when I swung those arcs up to my base, I took those points up to the apex line. So I've got I got my orientation lines across here. Even the outside surfaces of my cone become kind of these orientation lines too. So then I went ahead and numbered them. I just started this with 1, 2, 3, 4, 5, 6, 7. And because this is like not pushed off away from me or coming towards me at all, I mean, it kind of is, but it's from 8, 9, 10, 11, and 12, they all kind of line up with these. So, 6 and 8 are going to kind of have the same line. 5 and 9, 4 and 10 will have the same line. 3 and 11 and 2 and 12. So what I'm saying is all these orientation lines, they have an existing line going around the back side of this cone. So let me just draw in this top view. What I want to show you is that, let's just take the length of one of these. So what I'm showing you is that I've actually, by doing this little interpolation here on the bottom with off my node points that way, kind of basing them off of point 1 here and pulling these things and then having that arc sweep me up to where it meets the base of the cone. By doing that, I pick up true length. So I'm going to prove it to you right now. So let's take the true length of this line as I've drawn this orientation line. So let me just go ahead and snap that, and I'll just leave that dimension on there for right now. So that's almost 12 and 3/4. So, and that would be kind of like orientation line number 2 off of node point 2. So in this view, the length of line 1 here is a true length here too. So I'd actually see a true length on the very edge of that. Same with number 7 here, out here on this end. I just want to prove it on kind of node point 2, and the way I did this, I pick up true length. So now let me go and just kind of draw in a top view, which is unnecessary, but I just want to show you this. So you don't have to do this, you can just watch this. But what I'm going to do is I'm going to just, and what you might see me do is, I think I got another layer here. So let me just put this, I'm just go ahead and draw on another layer, because I'm going to turn this stuff off that I do. But let's project my object up to a top view. So let's take the overall width of up here, just arbitrary length up, and I'm going to do that here also. I'm going to bring this up perpendicular. This is just kind of like locking in the width of my, and maybe I'll take a line over here. This is locking in like a width of the upper round diameter. So this should be able to, if I was to draw this in, kind of this should lock in what the top view looks like right now. Top view of the smaller diameter is a circle, and off this center point, these should line up right here as the top of my circle here. So this thing should have a dimension of, top of my circle, whoops, sorry, this thing should have a dimension of 4.5. just using projection lines, I was able to get that in there. So let me just kind of pull this up just a little bit. Okay, so I've got my 4.5 inch top in. Now let's go ahead and draw in the 4.5 inch, or sorry, the 8 5/8 bottom in. So a number of ways I could do that. If I just use the laws of projection here and just take up 0.7 up here to an arbitrary length, and if I took up 0.1 off the base, it's going to be the same point here. So they actually line up here. And so now essentially what I've established is a new, just kind of, I can draw a new line in here. This would be the overall width of the bottom also out to this point here. And it probably has a midpoint on this line. So if I was to draw the base round would look like this. So I'd be looking for the midpoint off this line here, right there. Kind of tricky. There's a lot going on there. They don't exactly line up. I'm waiting for that midpoint to show up, and that's got to be the midpoint for this circle right here. So now I've just kind of drawn in like a top view of that with the small diameter coming towards me and the base down below. And I can kind of prove this by, I'm going to go ahead and dimension this out, make sure it's 8 5/8. Pull this dimension down. 8 5/8 looks good. Okay. So you might see me like almost get rid of this, and I might dimension this out the other way just to get it off my drawing a little bit. This should be 4.5 inch diameter here. Yeah. Because what I kind of want to do is do my standard center lines on these. I'm just gonna talk about this for just a minute here, but these have quadrants I can snap to. Well, close. That is way off, but let's redo that one. I want to grab the quadrant of the big round and the quadrant here. Yeah, there we go. That's the center line going that way off on the y-axis of the big. And I already have one that's kind of the center line. This one here is the center line of the large that I used when I projected. But that's the center line of the large going the other way. And so this is, and then here's, let's do another center line for this guy. That should be quadrant. I'm just making sure that was quadrant and dimension line. So okay, so as I analyze this, I just wanted to show you like the top view. Yeah, this is center line of base, this is center line of top. It's pushed over that far, but they are on center the other way, which allows me to draw down from the front view to have those lines line up in the front view, or the node points, I should say. That's why I was saying that 6 and 8 node points line up. You know, they would hit the same point on this side of the circle here, whether they're here or on this side even. So yeah, I only really need to kind of keep track of 7 of those points down below, just my half of my pattern here. So from last thing I'll show you is just what this looks like with those orientation lines in this view. If I was to divide, now I'm looking at a whole circle here, so I would divide this by 12, and I would divide this one by 12. Sorry, choose divide again. So I'd have these node points, and then I'd be able to pull these lines. So points 1 on both of those line up. They are kind of the flat bottom of that cone. Point 2 on the big one is right here, and point 2 on the upper one, on the littler diameter, is right there. So those two would go together. And this one would be point 3, so this one should be halfway there. And I think I called the center line point 4, which is going to be that one. And then this would be point 5, and it should have a point 5 that it lines up to here. Yep. Yeah, and you might see me take this and just tuck this out of the way. I guess that was the projection line to lock in the top overall diameter there. I'm just gonna tuck it away, just get it out of my way for just a minute. But like I said, this is unnecessary. So if you just sit back watching this, I'm just wanting to show you that we can kind of use the way we did squared arounds, where we're taking a top view. I mean, these are, and this one lines up with, that's 0.7 there. So I've got one that's straight in line with each other. I don't even need to do anything there. There's 2, 3, 4, 5, 6, 7. I'm ready for 0.8, which should be the next node point around here. 8 there. Gotta be careful here. There's a center line there. I don't want to. There it is. There's 0.8 and 0.9. This does kind of show what those orientation lines look like. And this is back to the quadrant here, 0.10. And should be another one, 11 here somewhere, 11 and 11. And then last one is this one, 12. Yeah, this just shows, and this shows the relationship that they are kind of the same length, hitting the same points, like points, this orientation line 12 and 2 are the same length, 11 and 3 are the same length, 10 up here and 4 down here, they're the same length. So I just really need the true lengths that are associated with half this pattern, and that's just because they do, the large diameter and the small diameter line up kind of in the y-axis here on the same center lines, just not in the x-axis. And so it's, I guess, yeah. So what you would do with a squared around to figure out the true length, if you remember, we would want to relate this to the elevation, and what you would do, if you remember, is we would copy the elevation line. Like, so let me copy the full elevation line, because the beauty of having this apex here is that it does make this nice Pythagorean 90-degree triangle here that we can use Pythagorean theorem. And so I'm going to copy this one, maybe, if I can find it. There's one in here that should be the right length. It's not that one. And maybe it's buried now. Should have been a green one. So let's just put in a new one. And maybe I'll just make it like a, not red, maybe I'll just make it like a white for a minute. I'm still drawing on the same layer where all this stuff is going, but this line, I just want to be able to copy this overall height of my right triangle here, which is kind of what we did with our squared arounds. I needed like this elevation, even though my true elevation is down in here. I'm actually pulling the overall elevation up to, which is where I've referenced this dimension. You know, when I took the length of node point 2, I am including in that overall length like some of the space that doesn't really exist, that's above my, it does exist in that it comes up and hits the same apex, but it doesn't exist. I'm going to cut off my part here, you know, I'm just going to take and cut this off. And so anyway, but what I'm going to do is I'm going to copy this up and make a development triangle like we did with squared arounds. I'll just copy it from this base. That's the overall length of the total triangle that has the information I need for my pattern, plus some extra space up in the y-axis that goes to the apex. So and that's easy to break that up. Once I go to my pattern, I'll show you that. But to separate where my pattern that I actually need is, and get rid of the pattern that I don't need. But at first, this just shows that if I use the same kind of triangulation techniques using the top view and front view, I get the same thing as what I just did really quick in the front view without doing this. This is just extra information. So what I would have here is a line coming out. The arbitrary, every time we did that, we would pull like the overall elevation triangle over, and then we would just take this out an arbitrary length that has no specific length. I just created a 90-degree kind of mock-up that I can triangulate with. And what we were doing is we were kind of taking the difference, like let's just say we're going to work from point 1 here. So what I'm going to do is I'm going to kind of call this point 1, which is really, it does relate to 1. That's what I named it down in the front view here, is point 1. So I'm going to be pulling everything from point 1 and relating it over there to that triangle. And so if I say on the top view here, because I'm looking for the difference between the upper round to the lower round as they kind of fall away from me in this view. So what you have to remember is don't think that you're going to take, and I need this measurement over here to this node point too, because that's on the upper circle, and that's not what I want. I want the difference between the upper circle point 1 and the lower circle point 2 there, which is right there. And it shows that it's the same as the lower circle point 12. Those guys intersect at the same point too. So it's like that's the top distance I'm picking up, and I would be pulling all these like circles to these like from point 1, yeah, and to point 3, 4, 5, 6, 7. And so if I do that, let me just show you. Now I'm going to copy this over to my development triangle, because it's kind of telling me what the difference is between these node points. And let's drop that on there, and then let's switch this to a solid line. This should be like a true length of like node point based off the elevation of my pattern out to that first node point, which is node point 2 that's not in line. Over here it's going to be this guy. So that should be I haven't pulled the dimension yet, but it should be the same dimension as 12 and almost 3/4. So if it isn't, I've done something wrong. So let's dimension that now with no further ado. Let's see if my measurements line up. Yes, they do. So essentially what I'm just showing you is, rather than having to do a bunch of extra work with a development triangle, I can just fast track this in the front view, and it's because I'm using point 1 where they all line up in the front view. Like I'm using point 1 here, and I'm always just pulling from that point. I'm using that as my reference point, and it is a 90-degree angle in the front view, and I just pull that, and that's why I did a little bit of a different pull off my node points to get my orientation lines. I incorporated that into that right off the bat, which is a little trick. That's a little drawing trick that old layout guys would use. Rather than having to do a whole nother view of this, they just said, oh, I get, this is somebody that understands what they're looking at, and they just know that on point 1 in this view, I can see that I can just pull this around and just incorporate, because I'm using, essentially what they're doing is they're using this as a development triangle in their front view, and they're not, and we're not even telling you that's what I'm doing, but that's what I'm doing. It's already set up as a development triangle. Just use it, use it with my reference work that I'm doing down here, and get these orientation lines. So anyway, I just wanted to show you that this works to get the right true length, and it's quicker than having to draw in a whole nother projected view and then pull that to a development triangle and then actually pull the true length. So I'm going to stop this video here. We're going to pick up part 2. We'll just be finishing what the pattern looks like. So we'll catch you then.